Alright, let's look at an object that's going to be floating inside of a beaker. We have a beaker, and it has a certain level of liquid inside of it, and the object is floating inside of the liquid, not touching the bottom and not above the surface. So the volume of the entire object is below the surface of the liquid, floating, suspended in the liquid. So you basically have the buoyant force, F sub B, acting in the upward direction, and the gravitational force acting in the downward direction. The net force, F sub net, is equal to the buoyant force minus the gravitational force. Now, if we think back to Archimedes' principle, the buoyant force is equal to the weight of the displaced fluid, and that's the mass of the fluid times gravity, and the force due to gravity on the object is equal to the mass of the object times gravity. So the net force acting on the object is equal to mfg minus m naught g. Well, we're dealing with densities of objects inside of a fluid, so density is equal to mass divided by volume, and mass is equal to density times volume. But in this case, we have the mass of the fluid is equal to the density of the fluid times the volume of the fluid, and we have the mass of the object being equal to the density of the object times the volume of the object. So if we rewrite the force net equation, that is now equal to rho F V F G minus rho naught V naught G. We're going to factor G out. So the force net acting on the object is rho F VF minus rho naught V naught times G. And that's the net force acting on the object suspended. Now, let's say that that net force is equal to 0 and it's not moving anywhere. 0 is equal to rho F VF minus rho naught V naught times G. And so we have 0 being equal to, distribute the G back in, rho F VF G minus rho naught V naught G. Add this to the other side, and you get rho naught V naught G being equal to rho F VF G. Gravity cancels, and so you have a relationship with only densities and volumes. Now, if you divide this side by rho F and divide this side by rho naught, you have rho naught over rho F being equal to VF over V naught. Now, you have ratios of density to volume. So you can basically look at this and analyze what this might be. Let's say that the volume of the object is equal to the volume of the displaced fluid. Because if you put an object inside of a fluid, it's only going to displace fluid equal to the volume of the object. So VF over V naught is equal to 1. And this means that rho naught would be equal to rho F. So if an object had no net force acting on it, and it was suspended floating inside of a liquid, then the density of the object is equal to the density of the fluid. Alright, now let's go back to this and let's say that the object is actually floating above the surface. So it's floating up. If it's floating up, then we can use this equation, rho naught over rho F, being equal to VF over V naught. If it's floating like this, above the surface, then this equation, this relationship still holds because the net force is equal to 0. The object is actually suspended. Buoyancy is buoying it up and gravity is pulling it down, and the net force is equal to 0. But in this case, it's above the surface of the liquid. Now, what this means is that the volume of the displaced fluid is going to be less than the volume of the object. And the density of the fluid is going to be greater than the density of the object. So we can make a comparison using what's left of this equation for where this object is located inside of the fluid. If the object is partially submerged, then the density of the object will be less than the density of the fluid. If the object is fully submerged, the density of the object is equal to the density of the fluid. And let's look at the case where the object is actually all the way on the bottom. If the object is all the way on the bottom, then the density of the object is greater than the density of the fluid. You can look at this in terms of ratios for what you're going to get if you set things equal to 1. And look at numbers, like if the density of the object is 1 and the density of the fluid is 10, you have 0.1, and that's a small number, so the density of the object related to the density of the fluid, if you get a decimal point, the density of the object is less than the density of the fluid, therefore it floats. So if an object has a density less than the density of the fluid at which it's placed in, it's going to float. If the object has a density that is greater than the density that it is placed in, the object is going to sink. Okay?